Welcome to lesson 5 of module 9, Load Balance the REST API on EC2. So in this lesson, we're going to go into the EC2 console and we're basically going to set everything up so that at the end of the lesson, we have a working load balanced API. We're going to start by spinning up a new API instance on EC2 from an existing AMI. We have an existing image that already has the API available, and we're going to basically go through the process of using that image and spinning up this new instance. We're then going to define the load balancer in EC2, and we're going to add 2 instances into that load balancer. And at the very end, we're going to hit these instances through the load balancer. So we're no longer going to consume the instances directly, we're going to hit them and we're going to basically consume the API through the new load balancer that we have set up. All right, let's go right into it. All right, so we are going to start with a single running instance. This is a predefined instance that we are now running on EC2, and the instance has the API deployed and accessible through an elastic IP, through a public IP. So we can now switch to the REST client and we can hit this already started API and we can make sure that everything works as expected. So let's do that. We are seeing the 200 OK, so this particular instance of the API is deployed correctly. Now let's switch back to the EC2 console and let's start another instance of this API. Remember that our goal here is to set up a load balancer that directs traffic to multiple instances. And of course, when we create this new instance, we are going to use an AMI, which is a predefined image that we can just start, and that is going to be identical to this image, which has everything configured already. Because the point here is not to go through the deployment and creation of the image, the point here is to focus on the load balancing. And there we have it, a second running instance where our API is now deployed and ready to be accessed. The only other preparation that we're going to do here is we're going to associate another elastic IP to this new instance. And now with this other instance running, let's verify it in the exact same way. Let's just hit the API and let's see that it responds and that it actually responds with data. So there we have it. We are now running this second instance with our fully deployed and accessible API. So now that we have both of these instances running, we are going to move to the next step. And we're going to set these up in a cluster and with the load balancer running in front of them. We're going to, of course, use the elastic load balancer in EC2. The very first decision here is, should we route at the transport layer or should we have the routing done at the application layer? Remember that HTTP is an application layer protocol. And given the type of system that we are running here, given that we're running an HTTP-backed REST API, we are of course going to go with the application load balancer here. Now let's set up the basic configuration of the load balancer. Let's make sure that this is going to be an internet-facing load balancer that we can then just hit and consume. And let's also make sure that it's going to run on port 8082. And that's simply because the applications themselves are deployed on 8082 that can easily be changed in the application itself, and the load balancer can easily be reconfigured to change the port as well. But for the time being, that's not our focus, so we're going to run on 8082 just as the application itself. Now, once we've selected our VPC here, we're going to have to set up 2 availability zones. Both of our instances are running in US East 1C, so of course we're going to select that. And we're also going to select one more just because that's a requirement when setting up this elastic load balancer. Now this is definitely an interesting point in the configuration. We're now defining the health checks that this load balancer is going to use when it needs to determine if the instances are healthy or not. That can be a very simple ping, or it can be something more complex. In our case, we're simply going to hit one of the Spring Boot actuator endpoint. We're going to hit /health, and that is going to determine the health of the application. That is what the load balancer is going to ping. Alright, so let's do that. And there we have it. We are now fully configured with a functional health check. However, there are definitely some interesting advanced features here. So notice that we have a lot of options and a lot of flexibility to configure things like what is the number of times that the ping should succeed before the instance is considered healthy, or of course unhealthy, what is the maximum timeout of the ping, what is the interval of the ping, and even what kinds of success codes we are expecting. So for example, if we're expecting that our endpoint, our health endpoint here, could result in a redirect, then we would basically just include 301 right here. So if we do that, a 301 response would be considered a healthy endpoint. Of course, we won't do that in this case, and we'll just change one of the defaults. So now it's only going to take 2 consecutive successful pings in order for an instance to be considered healthy. Alright, let's go forward. And now the final step in this configuration is going to be defining the actual instances that are going to be in this load balancer. So in our case, we only have 2 instances running here, and of course we're going to add them both. And there we have it. This is our fully configured elastic load balancer. We can now hit create and we're going to see everything running. We're now looking at a fully functional elastic load balancer. Now let's verify how many healthy instances we actually have in this load balancer. And for that, we're going to have to check out the target group right here. And for the time being, the health checks are still running. Notice the status here is initial. So basically it says that we need to wait and we need to allow the health checks to run. So we're now going to wait until the load balancer will determine that these 2 instances are actually healthy. And there we go. We are now looking at 2 healthy instances registered in this target group, which of course is the only group that the load balancer uses. Okay, so now for the final step, let's actually hit the load balancer. That is of course the entire reason for creating a load balancer. We want to be able to send traffic to it and make sure that that traffic is actually hitting one of the backing instances. Alright, so let's do that. Notice that we are grabbing the DNS record here and we're now going to simply use that. And that is it. We are now hitting the load balancer and we are seeing the API respond. In this case, of course, we're getting prompted with basic authentication. So let's run through that. And there we go. We're now getting the data as we expected, and we're getting the data through the load balancer. With a stateless API implementation, we are now able to create a clustered environment in just a few minutes. So the load balancer that EC2 provides is super powerful, and although not as flexible as some of the more advanced solutions on the market, it's definitely powerful enough to deal with quite a diverse range of scenarios. This is built for production. It's built so that it can handle a lot of traffic, especially if you're already running on EC2. This is definitely a nice feature to understand, and certainly a powerful feature when we're talking about stateless APIs. Alright, hope you're excited. See you in the next one.